In addition to defending a plant against its enemies, biotechnology can also help bring a more desirable product to market. Unfortunately, however, sometimes the cleverest biotechnologists can fail to see the forest for the trees, or the crop for the fruits. So it was with Calgene, an innovative California-based company. In 1994, Calgene earned the distinction of producing the very first GM product to reach supermarket shelves. Calgene had solved a major problem of tomato growing: how to bring ripe fruit to market instead of picking them when green, as is customary. But in their technical triumph, they forgot fundamentals. Their rather unfortunately named Flavor Saver tomato was neither tasty nor cheap enough to succeed. And so it was that the tomato had the added distinction of being one of the first GM products to disappear from supermarket shelves. Still, the technology was ingenious. Tomato ripening is naturally accompanied by softening, thanks to the gene encoding an enzyme called polygalacturonase, PG, which softens the fruit by breaking down the cell walls. Because soft tomatoes do not travel well, the fruit are typically picked when they are still green and firm, and then reddened using ethane gas, a ripening agent. Calgene researchers figured that knocking out the PG gene would result in fruit that stayed firm longer, even after ripening on the vine. They inserted an inverted copy of the PG gene, which, owing to the affinities between complementary base pairs, had the effect of causing the RNA produced by the PG gene proper to become bound up with the RNA produced by the inverted gene, thus neutralizing the former's capacity to create the softening enzyme. The lack of PG function meant that the tomato stayed firmer, and so it was now possible, in principle, to deliver fresher, riper tomatoes to supermarket shelves. But Calgene, triumphant in its molecular wizardry, underestimated the trickiness of basic tomato farming. As one grower hired by the company commented, "Put a molecular biologist out on a farm and he'd starve to death." The strain of tomato Calgene had chosen to enhance was a particularly bland and tasteless one. There simply was not much flavor to save, let alone savor. The tomato was a technological triumph, but a commercial failure. Overall, plant technology's most potentially important contribution to human well-being may involve enhancing the nutrient profile of crop plants, compensating for their natural shortcomings as sources of nourishment. Because plants are typically low in amino acids essential for human life, those who eat a purely vegetarian diet, among whom we may count most of the developing world, may suffer from amino acid deficiencies. Genetic engineering can ensure that crops contain a fuller array of nutrients, including amino acids, than the unmodified versions that would otherwise be grown and eaten in these parts of the world. To take an example, in 1992, UNICEF estimated that some 124 million children around the world were dangerously deficient in vitamin A. The annual result is some 500,000 cases of childhood blindness. Many of these children will even die for want of the vitamin. Since rice does not contain vitamin A or its biochemical precursors, these deficient populations are concentrated in parts of the world where rice is the staple diet. An international effort, funded largely by the Rockefeller Foundation, a nonprofit organization and therefore protected from the charges of commercialism or exploitation often leveled at producers of GM foods, has developed what has come to be called golden rice. Though this rice doesn't contain vitamin A per se, it yields a critical precursor, beta-carotene, which gives carrots their bright orange color, and golden rice the fainter orange tint that inspired its name. As those involved in humanitarian relief have learned, however, malnutrition can be more complex than a single deficiency. The absorption of vitamin A precursors in the gut works best in the presence of fat. But the malnourished whom the golden rice has designed to help often have little or no fat in their diet. Nevertheless, golden rice represents at least one step in the right direction. It is here that we see the broader promise of GM agriculture to diminish human suffering. We are merely at the beginning of a great GM plant revolution, only starting to see the astonishing range of potential applications. Apart from delivering nutrients where they are wanting, plants may also one day hold the key to distributing orally administered vaccine proteins. By simply engineering a banana that produces, say, the polio vaccine protein, which would remain intact in the fruit, which travels well, and is most often eaten uncooked, we could one day distribute the vaccine to parts of the world that lack public health infrastructure. Plants may also serve less vital but still immensely helpful purposes. One company, for example, has succeeded in inducing cotton plants to produce a form of polyester, thereby creating a natural cotton-polyester blend. With such potential to reduce our dependence on chemical manufacturing processes, of which polyester fabrication is but one, and their polluting byproducts, plant engineering will provide ways as yet unimagined to preserve the environment. Monsanto was definitely the leader of the GM food pack, but naturally its primacy was challenged. The German pharmaceutical company Höchst developed its own Roundup equivalent, an herbicide called Basta, or Liberty in the United States, with which they marked Liberty Link crops genetically engineered for resistance. Another European pharmaceutical giant, Aventis, produced a version of Bt corn called Starlink. But Monsanto, aiming to capitalize on being biggest and first, aggressively lobbied the big seed companies, notably Pioneer, to license Monsanto's products. But Pioneer was still wed to its long-established hybrid corn methods, so its response to the heated courtship was frustratingly lukewarm. And in deals made in 1992 and 1993, Monsanto looked inept when it was able to exact from the seed giant only a paltry $500,000 for rights to Roundup Ready soybeans and $38 million for Bt corn. When he became CEO of Monsanto in 1995, Robert Shapiro aimed to redress this defeat by positioning the company for all-out domination of the seed market. For a start, he broadened the attack on the old seed business problem of farmers who replant using seed from last year's crop, rather than paying the seed company a second time. The hybrid solution that worked so well for corn was unworkable for other crops. Shapiro therefore proposed that farmers using Bt seed sign a technology agreement with Monsanto, obliging them both to pay for use of the gene and to refrain from replanting with seed generated by their own crops. What Shapiro had engineered was a hugely effective way to make Monsanto anathema in the farming community. Shapiro was an unlikely CEO for a Midwestern agrochemical company. Working as a lawyer at the pharmaceutical outfit Searle, he had the marketing equivalent of science's eureka moment. By compelling Pepsi and Coca-Cola to put the name of Searle's brand of chemical sweetener on their diet soft drink containers, Shapiro made NutraSweet synonymous with a low-calorie lifestyle. In 1985, Monsanto acquired Searle, and Shapiro started to make his way up the parent company's corporate ladder. Naturally, once he was appointed CEO, Mr. NutraSweet had to prove he was no one-trick